Hello everyone, how are you all doing? Well, in today's video, let's discuss the next part of functions where we're going to deal with the equality, constant, and identity of functions. Let's begin. First topic for today is equality of functions. Here we have two conditions that is same domain and f of x equals g of x. I know it is quite confusing. Let me put on an example over here. Here, let's say I have two sets A and B where I'm having function f. On the other hand, I put on two other sets, let's say 3, 4, 5, 6, E, F, G, H. Now in this, I'm putting on C, D, and here I'm putting on G. This is function T. Now what does the first statement tell us? Now we're going to equate F equals G. Alright, we are going to make these two functions equal. Alright, first condition says same domain. Now it means here A is our domain, C is our domain, isn't it? Now all the elements that are in A should be present in C, or all the elements in C can be present in A. Let us change the G function over here. Here let me write down 1, 2, 3, 4. Now our first condition is satisfied. Now the second condition says f of x equals g of x. Now what does this mean? Let us allow mapping at the first case, but always remember for mapping you need to have the same elements of B as that of in D. Fine. Let us put on A, B, C, D. Now this is not the end. Mapping really matters. Now if I say 1B, 2C, 3D, 4A. This is my mapping in function f. Now what if I do mapping in this manner in function g? They are not equal. Why? Why do I say that here? The domain is same. The elements in B are present in elements in D. Now what is this? Why are in the, they're satisfying the equality of functions? Why? That is because here one is getting mapped with B. On the other hand, if you see, one is getting mapped with A. That should not be the case. Here f of x should always be equal to g of x. Alright, if one is getting mapped with B, the other hand as well should have one getting mapped with B. Alright, now let us do the mapping similar to that of here. Alright, here the elements can be different as well. Let's suppose say D, C. It does not matter. Order really does not matter over here. Just the thing is that mapping matters. Now 2 is getting mapped with C. So 2 will get mapped with C. Let it be whatever the order it is. Now 3 is getting mapped with D and 4 with A. In this manner, we make the function f and g equal. Alright. On two conditions, they are the same domain and f of x is equal to g of x. Let us have a quick question on the screen. Here it says on what domain the functions f of x equals x squared minus 2x and g of x equals minus x plus 6 are equal. Now the question has already given us a clue that these two functions are equal. So let's equate them at the first case. X squared minus 2x is equal to minus x plus 6. Fine. Let us solve this further. You get x squared minus 2x plus x minus 6 equals to 0. Here it's going to be minus 6 equals 0. Now let us solve this quadratic equation that is there. Here if you see we have minus 6. Here I can take out minus 3 into 2. Isn't it? Now here let me write down in this manner, minus 3x plus 2x minus 6 equals 0. Now here, let me take down x common. Here I'll have x minus 3 plus, if I take out 2 common, here again I'll have x minus 3. Now what are the two things I have over here? X plus 2 equals 0 and x minus 3 equals 0. Here you're going to have minus 2 and 3 as our domains. Now you're going to write down a conclusion step saying that Therefore, f of x and g of x are equal. On the domain, you'll write it in this manner. On the domain, minus 2, comma 3. Alright, this is the end. Constant function. Now, in layman terms, I call it all elements in A have the same elements in B. Now, what does this mean? Here, let me put on an example. 1, 2, 3, 4, A, B, C, D. Now, this condition says that every element in A should have the same image in B. That means if I am mapping 1 to C, then 2 to C, 3 to C, 4 to C. This is known as a constant function, where all the elements in A are having the same image in B. Now, let me put on another example. This is way too simple. Let's say 159 ADM. Now, let's say I'm mapping 9 to M. Then every element in A should be mapped with the same image that is M. This is a constant function. Alright, these were the two examples. One more thing that you gotta keep here in mind is your range is always a subset of codomain. Alright. Now, how do you represent a constant function? Well, if I say A is equal to A, B, C, D. On the other hand, if I say B equals to 1, 2, 3, 4. Alright. Now, the constant function is going to be like this. F equals to, let's say I'm mapping A to 1. A comma 1. Then, I'm going to have B comma 1, C comma 1, and then D comma 1. In this way, I form a constant function. On the other hand, how do we form the equal functions, everyone? Well, if let's suppose say I have 1 comma 0, 2 comma 0, 3 comma 1. Okay, something like this. Now, what would be the equal function for this? Well, it will be like this. Let's say 2 comma 0, 3 comma 1, 1 comma 0. This is the equal function for this. Let's say f equals and g equals. F equals to g. Why? The conditions are satisfied. In this way, you represent an equality of functions. Alright. Now, one more thing. Order does not matter. Alright. The last topic for today, that is identity function. Here in layman terms, I can say that each element in set A has image of itself. Now, what do I mean over here? Let's suppose say I have two sets A, B. I have 1, 2, 3. I have 1, 3, 2. Now it means 1 should only get mapped with 1. 2 should get only mapped with 2. 3 should get mapped with only 3. That means here the elements should be mapped with the same element. Each element in set A has image of itself. That is what it means. This right over here is an identity function. Alright. Now let us take another example, making things clear. A, B, C. C, A, B. A, B functions, here I have G. Alright. Now, A should get mapped with A, B should get mapped with B, C should get mapped with C. This is what an identity function actually tells us, isn't it? Now, how do you represent these functions? Well, let's say A equals to A, B, C. Here, the identity function is going to be, here I'm talking about this example, everyone. Alright, so identity function of A is going to be in this manner. A comma A, B comma B, C comma C. Such a function is known as an identity function. You represent this in this manner. I hope you all enjoyed watching this video. Make sure you hit the like button, share and subscribe. Thank you.